Hello, everybody, and welcome to our web event about substation attacks and why a firewall is not sufficient. My name is Jan Hille. I'm Solutions Architect at Velotek, and I'm here today with Alexander Müller, who is VP for Product Management at Rhebo. Also with us today is my colleague Thomas. He will collect your questions. We will have a Q&A session after this presentation. Please feel free to post your questions into the Q&A of the Zoom. We will take some time afterwards to answer them. Now let's take a look into our agenda for today. We will start with a short introduction of the companies Rhebo and Velotek. Afterwards, we'll take a look on a classic substation network layout as it is now. Then we will answer the question why OT monitoring and anomaly detection is important and necessary, and how anomaly and threat detection in substation networks is carried out. After that, we will take a look onto a real substation attack, and also take a look onto early detection opportunities and why that is very important. Then we will say a few words about the Rhebo stability and security audit. And afterwards, we will present you our joint solution with Rhebo and Velotek. As said before, we will take some time to answer your questions at the end of this event. We might not be able to answer all of your questions. We will follow up these questions which remain unanswered via email afterwards. So please feel free to post any question you have into the Q&A, or if you're live on YouTube, into the comments. We will reach out afterwards. Okay, Alexander, would you please say a few words about Rhebo, please?
Sure. Thank you, Jan. Yeah, welcome also from my side. I do not have such a nice background, unfortunately, like Jan. As you can see, I'm sitting in my workshop due to the COVID restrictions now. But I think everything is okay. Internet connection is fine, so I guess it will be okay. Yeah, my name is Alexander Müller. As already mentioned, I'm responsible for product management at Rhebo. Rhebo is a software vendor that's based in Leipzig in Germany. It was founded in 2014, so we are still a quite young company. But we have a team of very experienced founders that have founded quite some companies in the areas of network analytics and network security. Our main goal is to provide solutions that ensure cybersecurity and availability, especially for industrial network operators. So we are not focused on, let's say, IT networks and IT security, but dedicated to industrial networks, or also sometimes called operational technology, OT. Our customers are usually critical infrastructure customers, and this means companies or operators in power generation, power distribution, transmission, oil and gas, water and wastewater. Yeah, I think this is a good introduction to Rhebo. You can, of course, visit our website. You will see my email at the end if you want to learn more. But as we want to talk about electrical substations today, I think Jan will now introduce you to the topic.
Yes, thank you very much, Alex. Just a few short words about Velotek. We have been founded in 1969. We are originally coming from the automation section, but we developed also to expert for digitalization and IT environments, especially when it comes to rugged OT environments. We are based in Lahr, which is not far from Münster in Germany. That is not far from the border to the Netherlands. Due to our different professions in the engineering team, we have both a strong OT and IT background, and partnering with the global vendors for substation automation, we bring solutions into the substations and into the power industry as well. On this slide, you see a picture of our Velotek substation server. This is one of our industry certified solutions, which includes IEC 61850-3 and IEEE 1613. We have quite a lot of other platforms in our portfolio, but this is especially for the substation segment very important. Now, as I said before, we want to take a look onto a classic substation network layout as it is now. We see the different layers here, down from the process level over the bay level, also called field level, up to the station level. And what we can see, we see a huge variety of different devices using different communication methods and also different communication protocols. Usually we see a firewall in the station level, which interconnects the substation to, for example, a control center. And this firewall can be seen as a barrier between the trusted substation network and the non-trusted network. And it can monitor and control all the traffic from and into the substation network. But what it cannot see is what's happening inside the substation network. And why this might be a problem, I would pass over again to Alex. He will say a few words about that.
Yeah, thank you, Jan, for the great introduction. Yeah, usually we start discussions with grid operators or substation network operators with this quite simple question. So, do you know what's actually roaming your infrastructure, or do you know what is happening in your substation networks? And I think, not surprisingly, the answer in many cases is no, simply to the fact that for a long time the substations were not really Ethernet-based or really considered networks as such. And did not require dedicated monitoring. But as Jan already explained and described, the substation networks change, they get digitalized. We have more and more devices actually being part of the network, and this, of course, changes also the requirements in terms of monitoring. What you can see here is basically statistics that we derive from a service that we offer to our customers. And this is a lightweight security and stability audit, where we basically bring our software into the grid network or the substation network. We basically monitor the networks for a while, and then we will analyze the findings and derive a report out of this. This is the data that we collected over 2020, I think, from a little more than 50 grid networks. And this basically means, or what you can see here is on the one hand that not surprisingly, in every second grid network, we see either things that indicate that we have insecure authentication methods. That means basically old protocols being used. We see a lot of unused protocols and services that are not actually used within the network, but are active and thus increase the attack surface. We see a lot of zombie devices, which means basically devices that where the operator is not really aware of that this RTU is still in the network and is communicating because it simply has been forgotten or things like this. And I think this is also some things, of course, vulnerable systems that we can explain somehow, because the grid network as such, due to the long investment cycles, but also due to the difficulties in patch management and other security practices, this is simply a case that is hard to avoid for a grid network. But what is really surprising to most of our customers is the last point here, that we have in 1/3 of the cases we see internet connection. There are sometimes we call it a MUF, the OT gap. That means a lot of our operator customers, when we first talk to them, they basically say our OT network is isolated from the IT network, and there's an air gap, or there's this and this measures that basically avoid that there's communication between the IT and the O network. As you can see here, in 1/3 of the cases, we actually see internet communication in the substation networks. This is not only due to cloud connectivity, but also, of course, a lot due to, for example, remote access services that also have increased due to COVID times. And this is something that, of course, is always used then as this OT or air gap as an excuse to basically increase security practices or improve them. Yeah, I think this is quite obvious that from this point that we have to do something, especially as critical infrastructure operators. We have to improve industrial network security. It's not only a legal compliance. I think it should be a core goal of all of us. And yeah, in the next slide, I think we can see how our solutions actually can help here. Yeah, as mentioned in the introduction already, our main goal is to ensure cybersecurity and availability for OT and IoT networks. We see cybersecurity and stability basically as two sides from one coin. And actually, there's three main benefits that you can get from a solution like ours. The first one is asset discovery and asset inventory. What our solutions will give you is in real time and always up-to-date asset inventory that includes all devices like RTUs, HMIs, and as such that are communicating in your grid network. And also, of course, including their properties such as vendors, types of devices, firmware versions, and IP addresses. And this, of course, is a great starting point in your security journey. If you follow a security framework like IEC 62443, for example, then usually the first step is find out what you have, because only when you know what you know what you have to secure. And this basically asset inventory is a great starting point for any risk analysis or impact analysis that you might want to conduct. The second benefit is then anomaly and threat detection. Based on this basically map of the network that we have, that means we know now all the devices that are on your grid network. We know who is communicating to whom. We use then or utilize deep packet inspection and anomaly detection to basically analyze all the industrial protocols that you are using. And I analyze them down to the value level and basically learn the assets behavior. That means we will learn that a certain device is an HMI and communicates with these types of other devices, like with the engineering station and whatever, or with the RTU. And we will basically use then this asset behavior that we learn for every asset to do anomaly detection. That means as soon as an asset then starts to behave differently, for example, start an HMI that starts doing things that usually an HMI is not supposed to do, like, for example, updating the firmware of an RTU, then we can alert them, of course, on these anomalies and detect all kinds of malware, network discovery activities, but also potential malicious behavior that is not typical for your assets. And the last benefit that I want to mention is exactly what I said in the beginning, with stability or availability and security being two sides of the same metal. What we also have in the products is network condition monitoring functionality. That means we also will monitor basically all network connections and network links and constantly check them against properties. So this allows us, for example, to detect issues such as network congestion or faulty network equipment such as switches before network outtakes actually then can happen. So this is basically the 3 times of benefits and value you can get from the solution. But then the question is often, how can this actually work? So how can I actually monitor a grid network? And on the next slide, we can then basically see how this is usually done in the grid network. Because of course it's a challenge, because we have at the end, it's not an IT network that in most cases is quite limited to, let's say, to a geographic area, to a building, or maybe to some buildings. It's really a network that spans thousands of square kilometers of distributed resources and substations, for example. So how do we monitor this such a network in an efficient way? As most of the connections and control network connections usually then terminate in one or more control rooms within the grid operator, usually we start by deploying our solutions next to the control room. This means our controller, this is the black box you can see here in the copper band, is usually deployed in the server room next to the control room and is monitoring all the network links that go in and out of the control room and go to the substations, to the distributed energy resources like wind parks or whatever you have attached to your control system. The appliance can be used as a physical or virtual appliance, also on the substation server, for example, from Velotek. And then, of course, we provide, as you can see here also in this copper band, we provide then a user interface with dashboards that is usually then used by the operator directly next to the other screens from the control software. We also have, of course, then interfaces. Sometimes operators might then want to connect the solution, for example, to their control room software, so that directly they can, for example, light a red light when there's a high priority alert detected by the solution. Or we can connect it also to IT security tools like SIEM systems, for example, in case you have them and want to connect them and feed them with the threats and alerts that our solution detects. But while this approach has the advantage of very fast ramp up, so we need usually only a limited amount of hours to deploy the solution within the control system network and attach it to the usually not more than 1 to 5 network links that go in and out of the control room. And this is really a good first step to monitor. It also has some drawbacks. And this is actually then or becomes obvious when we look at a typical substation and see why this approach here gives us not the visibility we need when we want to monitor on the substation level. On the next slide, we can see basically when looking at substations such as primary and secondary substations, as Jan already introduced, they have tremendously changed over the last years. We have not only Ethernet and IP-based communications, we have also new standards like IEC 61850. We have a vast amount of devices and communication that is now happening within the substation network. And those substation networks are usually not isolated from the outside world. So there is no such thing as an isolated substation. Of course, you have a connection to the control room on the one end, but there's also, of course, physical access. So there are suppliers, there's stuff going in with an engineering PC, with a test laptop or whatever, and connecting it to the network. And of course, there's also a lot of remote access via VPNs or even cloud connectivity that is happening. So we should not treat a substation network anymore as an, let's say, secure by design network because it has no access from the outside world. So when we want to now know what is going on within the substation network, it's not sufficient anymore to go with the centralized approach that I described in the slide before. Because at the control room, we only will see what is happening within the substation once it has an impact on the process itself. That means on the power generation or power transmission process. When we want to be able to detect problems before they actually have an impact on the grid operations, we need a sensor or sensor technology directly within the substation network that basically, in the same fashion as in the centralized monitoring, detects all assets that communicate within the substation, detects for all assets and learns the behavior of those assets, and also is able to detect when, for example, a new asset like a new laptop, a new engineering station comes online within the network and starts to explore it or whatever. So usually typically in such situations, we as Rhebo utilized small industrial PCs. You can see them here in the picture as the copper small industrial PCs, and we deployed them via mirror ports or dedicated network taps next to the central switches in the substation. We connected them to our central appliance, and then we are able to monitor the substation network. But of course, this is an approach that you can do, but usually, of course, we have tens to hundreds of substations, and this is quite a significant deployment effort, not only from having to bring in this physical devices into the substations, but also the added complexity because we need to have then dedicated connections and bandwidth assigned, of course, between this industrial PCs and the central appliance and whatever. What we now get as main benefit from the Velotek solution and from the automation server is that we can basically utilize this platform within the substation and utilize it to bring our functionality directly on the hardware that is already available in the substation. And you as a customer or as the grid operator, you can usually utilize this one hardware platform then not only to deploy the Rhebo sensor technology or our central interface, but you can of course then also utilize this platform to co-deploy other applications that might be important and might be needed in the substations. So this joint solution that Jan will explain later on really helps our customers to have a more easy and convenient way to also monitor substations and come from a central monitoring approach to a real distributed approach of monitoring that is then able to really cover 100% of the network. And while this was quite theoretical, I think in the next slide, I want to discuss this on a real example. So what you can see here is an illustration of that is based on an attack on an electrical substation in Ukraine back in, I think, 2016. All what I will be saying now is mainly based on the great analysis that was done by the SANS Institute on this crash override named attack. You can read up on the SANS Institute when you want to know more, because I will only focus on some aspects that I think are very important. What you can see here as the boxes is an illustration that's following loosely the Mitre attack framework for ICS systems. And I think this is a very nice way to basically illustrate and talk about the cyber attack. So what you can see in the copper boxes are the phases of an attack. So we have initial access, which here means initial access to the grid network or industrial control system. And then we go through all the phases. Then we have discovery. That means the attacker tries to find out where are my actual targets and how do I get from the point where I am now to the targets. And then we have more to the right side, we have more the functions that are then basically really impacting the process. So we have things like inhibit response. That means I want to avoid that somebody can basically undo my actions or my activities. We have impair process. That means I want to basically cause problems with the process or cause changes from the process not to happen. And the last stage, of course, is impact, which basically means usually change or damage to the process. And in industrial control systems, this always has to be considered that this can, of course, then also cause damage to life, environment, and other very important things. In the case of this attack here on Ukrenergo transmission system operator in Ukraine, the ultimate impact wasn't very high because the attack did not fully succeed. But at the end, circuit switches or circuit breakers were caused to strobe and basically switch on and off very repeatedly and caused a power outage for, I think, a little more than 6 hours for a main part of Kiev. Yes, so when we now start on the left page, because then we see that the initial access here, you can see, and in the bottom, in the white boxes, you see then basically what in this attack was used. You see data historian compromise, which basically means that in this case, there was an SQL server on the substation, and this SQL server was used as an historian. That means a historian, this is a server that is used by the assets within the substations. That means by RTUs and by other process relevant assets to basically log their data, log their performance data, and log their process data onto. So this server is an ideal target then for the attacker because all of the assets within the substation were able and had allowance to basically communicate to this SQL server. Whereas it is not basically known how the attackers were able to get the initial access to the corporate network of Ukrenergo. They used at the end valid credentials to basically access the first asset on the ICS or on the OT network, which was this SQL server. And that means, and this is true for a lot of cases, there's always the human factor. A firewall can prevent you when somebody tries to brute force or access you from the outside world. And of course, you need a firewall to segment your networks and also to prevent obvious access from the outside world. But firewalls can only be one part of your security strategy. And in this case, for example, as there were valid staff credentials used to access the SQL server, a firewall would have not prevented this. So what at the end happened is from this SQL server, it was used basically to inject commands and basically to scan the networks for other valuable targets. And this whole phase from the initial access to the impact was around 2 weeks. So there was an opportunity window of around 2 weeks where we would have been able to detect that something strange is happening in the substation network. And basically this opportunity window could have been used perfectly by deploying an anomaly detection solution, for example, because an anomaly detection solution would instantly be able to spot that the historian no longer is just used as a data dump by other assets, but suddenly starts basically to scan the network and to access other assets on the network. So this is why I think it's very important to realize that there's always, especially when you have sophisticated attacks, there's always this opportunity window of early detection. But for this opportunity windows, to use this opportunity windows, you basically need behavioral monitoring or anomaly detection. Yeah, so with this, basically, I want to close a little bit and just give you a last remark on our audit that we already mentioned in the beginning. So if you want, you as an operator want to find out what's actually happening in your substation networks, yeah, feel free to contact us. If you already used the Velotek platform, then we can directly conduct this audits on the Velotek platform. And you can see here some of the pages of the report that is then generated from this 2 to 4 weeks monitoring within the substation. And also we will have a joint workshop on site that basically to discuss the findings that we had in our audit and also to discuss jointly how stability and security of the network can be improved. Yeah, and with this, I hand over to Jan to basically discuss the solution a little bit deeper.
Yeah, thank you very much, Alex, for the detailed explanation. As we learned now, it is necessary that we place some hardware in the substation network to make sure that we don't miss this blind spot that we have there. We saw that the sensors have to be installed there. We saw also that we need some controllers for the IDS system, which can be placed in the control system. And these solutions can be run on our Velotek substation server. The substation server is a virtualization platform, which means that you can run several applications as instances of virtual computers on one hardware platform. As I said before, it's certified IEC 61850-3 and also IEEE 1613. Therefore, it is possible to operate this device in a substation. This virtualization approach, as I just mentioned, is already seen very often when it comes to substation automation applications. As you can see in the picture on the right, we see, for example, running the HMI substation automation system and engineering workstation on this platform, each as an instance of a virtual computer, but all on one hardware platform. What we also see, we see an increasing interest we are building an, let's call it integrated security solution using our platform. And this is where our joint solution takes place. We integrated together with the engineers from Velotek and the developers from Rhebo. We integrated this solution as a virtual machine into our substation server. We can, of course, place just the IDS, the sensor on this hardware as separate installation, but we can also place it along with other applications, for example, a firewall or a log server. What we can also do, of course, we can start with one solution, for example, a firewall, and then add other applications as the IDS. As Alexander just mentioned, if we already have this platform in the substation, we can easily add the IDS, the industrial protector to this network because it's just a virtual application. So to sum up, with this joint solution, we enable you to place the Rhebo industrial protector directly in the substation. We are using state-of-the-art virtualization technology using the Velotek substation server, and it is possible to build up integrated future-proof security solution for the future for your substation with this approach. Okay, this is already the end of our presentation. We are quite a little bit short in time, but I think we should take the time to answer a few questions. Thomas, do we have some questions which we may answer now?
Good morning, everyone. Yes, we do have a couple of questions, actually more than we will be able to answer today, I think. So I'm going to pick out the more general ones, and the rest we have to follow up after the webinar. Singh from GP would like to know, what if my substation SCADA SAS system is not connected to the internet, but I can take remote support by OEM, occasionally connecting it to a laptop having internet access? Can the solution be used in that environment? I think that's for Alexander.
Yeah, thank you for this question. It's actually a great question. It ties a little bit to what I mentioned with remote access being a huge risk. I mean, when you deploy a VPN, and then usually you have to be aware that in most of the cases it will be a foot into the network. So this laptop that basically comes into the substation network, you always have to consider the case that it might be infected with malware, or that somebody might intentionally have prepared it in a way to basically then be able to compromise the substation network. So definitely, this is a potential source of malware. intentionally or unintentionally by the OEM or supplier. So definitely substation networks should be monitored, because this will then basically uncover if anything unusual happens from the point in time where the laptop is connected.
Thank you very much. Arno has a couple of questions that tie in together quite nicely, I think. The Rhebo controller, is it connected to a mirror port of the switch, or is it connected to an active port and is able to send communication on the network?
It can be done actually both ways. We have to say that in critical infrastructures, when we talk now here about a grid operation, for example, then usually I would say 99% of our customers use the system as a complete passive system. That means the system itself is connected usually to a mirror port and has no active way into the network. But this is just because the customers, we need to build trust. It's a new solution category, and we need to build trust with the operators, because before they also will allow basically to do active communication within the network. The solution itself supports also active means. For example, I mentioned the asset discovery in the beginning, where we basically learn about what devices you have on the network and what properties they have. This can be done passively. That means by only sniffing the network traffic those devices produce, but it also can be done actively by querying those assets about and asking them what firmware version do you have and the like. So we support active, also active means, but from a deployment point of view, both is possible, and passive is usually the first step done by most of our customers.
Thank you. Follow up. What's the amount of devices a single controller can monitor? Is the controller suitable for the SCADA data center, or is it best at the substation level?
Yeah, this is suitable for the data center. So usually then we will not, when it's a huge network, we will not then let's say have one physical instance, but we will use a virtual instance and scale it as needed. But it's no problem for the central controller to monitor 100K of assets, as 100,000 of assets.
Okay.
So on the sensor, usually in the substation level, you would have a sensor. The main need for let's say an interface on the substation level is not, from our experience, is not really, let's say, the performance requirements. That means having the need for a control in the substation, because there are so many assets that we need the power of the central unit. Usually it depends on operations. So when sometimes there's teams or stuff that is responsible for the substation, and it's not the same stuff then that is responsible for the main control room. And then the stuff from the substation, they want to have their own user interface. So the sensor doesn't come with the user interface. So then we would usually deploy a controller in the substation level, so that the local stuff that is responsible for the substation can remotely or locally access a user interface directly in the substation. But this is only done in huge substations. And then this controller can still communicate to another controller that is basically in the hierarchy above this controller. And so the central control room still has the same visibility. So the question is more or less not really about do you need how many assets are in the substation, but really where do you want to have the user interface, and where's the stuff that will operate the system.
Okay. And Devon would like to know, are there any industry standard manuals on the cybersecurity for substations and utilities? I have seen some ABB, Siemens, GE documentation. However, do we have manufacturer agnostic agreed upon standards?
Partly. Yes, so I think there's a lot of momentum in this space, and yeah, we see also with a lot of operators that they basically want to be vendor independent and want to have an approach that is not tied to one specific vendor. And we only can say this. We think this is a good approach. You can have, on the one hand, the mentioned standard. So a lot of our customers follow IEC 62443 as a general framework of how to conduct security. That means there's general concepts that always are always good to use, like zones and conduits and other really controls that help you to improve industrial security, no matter from which sector basically or which vendor you use. And then more specifically for the energy part, there's also an association in Germany. I think there's an equivalent also in the US with NERC-CIP that have basically directives that help you specifically in the energy space to know which processes, which tools, which controls I should use. In Germany, it's called the BDEW. It's the Association of the Energy Economy, Bund der Energiewirtschaft, I think, and they have white papers, for example, for the energy sector on how to improve cybersecurity there. And this is an independent association.
Okay, I think we can just squeeze in 2 more questions. One probably short one from Daval. Is it possible to get a sample report like the one you showed to have a look at it?
Yes, yes. Yes, when we will send this after the webinar. Yes, we have one available.
Cool. And the very last question before I hand back to Jan. There are more vendors do specific monitoring for OT, like Security Matters, Darktrace, Nozomi. How is Rhebo different from those vendors?
Yeah, our main differentiation centers around this stability versus security aspect. So, I mean, there is some vendors, as you mentioned, in this space, but they are more or less all very focused on the security aspect. So what we offer in terms of network condition monitoring and network health monitoring, this is the way how we want to differentiate in this market. It means not only offering the ability to detect cybersecurity threats, but also giving the grid operation staff things that they can use from day to day. That means, for example, I give you a cyber incident is still a very rare event in grid network. So we have, I think, over the last 10 years, we have maybe 10 cases that are described. I do not want to say it's not important to prevent such attacks and to monitor the networks for such attacks. But we think by having network condition monitoring available, we give the grid operation stuff also a benefit they can use every day. So a lot of our customers, for example, they will use the forensic data that is captured from IEC 104 or other industrial protocols. They will also use this data to basically analyze other operational issues that they have when there was equipment that showed misconfigurations or showed failures. Then they use this data also for basically increasing availability. And this is, yes, how we want to differentiate. That means having really the best network condition monitoring functionality within this solution category.
Thank you very much. And thank you for all the questions, even the ones we didn't get to. With that, I give back to Jan.
Yeah, thank you very much, Thomas, for the moderation of the Q&A. We are at the end of our event. Alexander, thank you very much for your detailed explanations. What was very interesting, I think we all learned a lot. One short notice from my side to an upcoming event. On 23rd of March, the World Energy Leaders Virtual Summit will be carried out. Our CTO, Joost Senner, will be participating in a panel discussion about IT and OT cybersecurity. Will be a very interesting event. I recommend that you take a look on that. If you want more information about the joint solution, the solutions from Rhebo and the solutions and platforms from Velotek, just write us an email. You see our email addresses on the slide. We will be happy to answer, as Thomas said, all your questions afterwards. So thank you very much, everybody, for joining today. Stay safe, stay healthy, take care. Goodbye, everybody.
Goodbye.